Welcome to Chem Help ASAP. Let's see a simple example of an E2 reaction. Be ready to pause if you want to think about the problem before I give the answer. Our reaction is shown on the screen, and our task is to provide the structure of the starting material. Pause here if you want to try this question on your own. I'll pause for about 5 seconds. We know that we're doing an elimination because of the title of the video. The reagent for this reaction, sodium methoxide, is a strong base. So that's consistent with an E2. When you make an alkene through an elimination, one carbon of the alkene was the alpha carbon, the carbon that had the leaving group. The other carbon of the alkene was the beta carbon, the carbon with the beta hydrogen. With that logic, there are two ways that we could have formed this particular alkene product. One, here is our alkene with appropriate carbons labeled as alpha and beta. Here is the same molecule with the halide, chlorine, on the alpha carbon and a hydrogen on the beta carbon. And remember, we started with the hydrogen over here already, so that's a second hydrogen on that carbon. 2, let's reverse the labels in our alkene. Beta and alpha. And then put in the halide and beta hydrogen. Both of these alkyl halides on the left are molecules that we need to consider. How do we decide which is the correct answer? Well, let's think about what each compound will form if we reacted with our reagent, sodium methoxide. The first compound actually has many beta hydrogens. And let's not forget these three up here. Sodium methoxide tends to give the Zaitsev product, so it removes the more highly substituted beta hydrogen to give a more highly substituted product. This would be our main product. The second compound would react in the same way. There are multiple different beta hydrogens, but only this one will give the more highly substituted alkene, the Satyseff product. Again, that is our desired product. So either of these halides is a valid answer to this question. I admit that I envision the upper halide as the correct answer, but both will give the product shown as the major product of the reaction.